Let us solve May June 2022, Unit 1, Section A. The first question is about power and energy. A machine has a power of 750 watts and transfers 150 kilojoules of energy during a time t. Which of the following expressions gives t in seconds? Now, you have to pay attention to the units of the quantities involved. The pressure is given in SI units watt. Energy is given in units of kilojoules. Now, kilojoules is not the SI unit of energy. Joules is the SI unit of energy. You are asked to give the expression for t in seconds. Again, seconds is the SI unit of time t. So, when you are writing the answer, all the units involved should be in SI units. So, first let's write the formula for power. So, power is energy over time. So 750 watts is energy 150 kilojoules. Let's convert kilojoules to joules because joules is the SI unit of power divided by time. Now rearranging the equation to make T as the subject. So T is 150 multiplied by 1000 divided by 750, which gives us the answer C. Question 2 is about materials. A sphere falls through a viscous liquid as shown. Which of the row which row of the table describes the upthrust and the viscous drag of the sphere as it accelerates downwards? So the sphere is moving downwards, it's accelerating downwards. So definitely there will be a force acting on it in the opposite direction of its motion, which is viscous drag. So viscous drag will act in the upward direction as well as upthrust. Now, coming to viscous drag is a resistive force. Now, resistive forces, we know resistive forces are the forces which oppose the motion of the object. So, if the object is accelerating downwards, this resistive force will act upwards. Since it's accelerating, the speed of the object is increasing. When the speed increases, the resistive force acting on the object also increases. So, this gives us two options, A and B. Viscous drag increases in both of these options. Coming to upthrust, upthrust is the force that arises due to the pressure difference, the difference in the pressure between the top and bottom of the object. Now in this case, if you look at it, when the object is here at this point, this is the pressure acting on this part, and this will be the pressure acting on this part of the object. Now this difference will remain the same as the object moves downwards. We know the pressure will keep on increasing as pressure on the object will keep on increasing as it moves into the liquid, deep into the liquid, because liquid pressure increases with depth. But what you need to consider is what we call upthrust is the force which is arising due to the difference in pressure between the top and the bottom part of the object, and this difference in pressure will remain the same throughout the motion of the object in the liquid. So your upthrust will remain constant in this case. So this gives us the option B, which is the correct option. Coming to the third question, which of the following is a scalar quantity? Now, scalar quantity is a quantity which has both magnitude and direction. Sorry, I'm sorry. A scalar quantity is a quantity which has only magnitude. Okay. Now, here, force is a quantity which has both magnitude and direction, because we say an example of force will be weight. We know weight, any object on earth, the weight of the object will always act downwards. Now, if we talk about an object falling through the air, again, the object will be having two forces acting on it. One is the weight of the object acting downwards, air resistance acting upwards. So both forces, when we discuss forces, force always has a direction. So this is not the correct answer. Momentum. The formula for momentum is mass multiplied by velocity. Now, velocity is the speed of an object, but in a particular direction. So, velocity is a vector, so momentum is a vector. So, B is out of question. C is also not the correct answer. Now, let's come to D. D is work. Work done is also called energy. Okay. Why is work done energy? Again, let us consider the object falling through air. Okay. Let's say the object was at a height from the ground. Now, for an object which is on the ground, sorry, for an object which is above the ground at a height, it has potential energy. Now, when you talk about this potential energy, if the object is falling, this object, when it is falling, it has two forces. One will be weight, so object can fall under its own weight. The other force acting on the object will be air resistance. So this object has to do work against the air resistance. So the object is doing the work against the air resistance, which is getting converted to energy. So this energy is kinetic energy, and we know energy is scalar. So work is also scalar. So this becomes the answer for question 3. For question 4, the graph shows the relationship between tensile stress and tensile strain for the material. Okay, which of the following gives a Young's modulus of the material? The formula for Young's modulus is stress over strain. So tensile stress over tensile strain, provided you have a straight line in the graph. Now if you look at it, you have a straight line, but it's slowly starting to curve, crossing its elastic limit, reaching a breaking point. So if we are having such a graph, if we find the gradient of a graph, it will give you the Young's modulus. So out of the 4 options given, we can leave out option A and B. Area under the graph is not giving you the Young's modulus. Stress divided by strain at the breaking point is also not the correct answer, because you have to calculate the gradient to find out the Young's modulus. So the available option is C. So you will draw a tangent to the line at the origin. So at the maximum curve, you will have to draw a tangent, and then you will find out what is the gradient of this line. That should give you the stress over strain, or the Young's modulus of the object. Question 5. A student determined a value for G by dropping a metal sphere from rest. Okay. The student measured the distance fallen and the time taken for the sphere to fall. The student obtained a value for G of 11.2 meter per second square. Which of the following could explain the difference between the student's value and the accepted value? The accepted value of G is 9.8 meter per second square. Looking at this investigation, so it is a free fall investigation which involves the formula S equals to half gt square. Now this is a core practical, and you will have to read and understand and study the core practical. Okay, so you will have questions based on this core practical either in unit 1 or unit 3. So let us come back to this question. So the 4 options given here are: the air resistance was negligible, the student's measured distance was greater than the actual distance, the sphere did not fall vertically, the student's measured time was greater than the actual time taken. Now let us look at the investigation again. So we will assume that the student is doing this investigation, carrying out this practical in the laboratory. So the equipment that he would be using is a meter rule to measure the distance fallen, and a stopwatch to measure the time taken. He is using a metal sphere to conduct this investigation. So metal sphere are smaller in size. So the surface area of the metal sphere is small. As a result, when it falls through the air resistance experienced by this metal sphere will be minimum. So you can neglect the air resistance experienced by this metal sphere when measuring and calculating the quantities. So the option A, the air resistance was not negligible, is not the correct option, because you can neglect air resistance in this investigation. The second option is the student's measured distance was greater than the actual distance. Now, the student is using, let us assume the student is using a meter rule to measure the distance fallen. When the student uses a meter rule, there can be uncertainties involved when measuring the distance. The student may not align the distance exactly with the starting point of the meter rule, which is with 0. So that can give you an uncertainty of plus or minus 0.5 millimeter. And when measuring the end point, which is, let's say if the student is measuring 90 centimeters, the student might not measure 90 centimeter. The student can measure 90.5, somewhere in between 90 and 91. So again, there will be another uncertainty of plus or minus 0.5 millimeter involved. So the total uncertainty can come up to plus or minus 1 millimeter involved. So this can give a value of a distance which could be different from the actual value, could be greater than the actual distance. So option B seems to be right for the time being. Let's move to the option C. The sphere did not fall vertically. Now, if we are doing an investigation in the laboratory, we are dropping a sphere. So the maximum distance that you would measure or that you would use for such investigations if you are conducting in a laboratory would be approximately 2 meters. Now, when we are dropping an object from 2 meters, unless and otherwise there is a horizontal force in the laboratory in the form of wind or air, it cannot provide an angle of fall for the sphere. So there is no wind in the laboratory, so which means there will be no horizontal force which will be pushing the metal sphere during its fall to the in the horizontal direction. So we can leave out the options C. The sphere did not fall vertically. So the sphere would have fallen vertically in this investigation. Coming to the fourth option, the student's measure time was greater than the actual time taken. If you look at this equation, S equals to half gt square, if the measured time increases, what happens to G? Let's rearrange this equation, keeping G as the subject. So G will now be 2s by t square. So if the measured time increases, what actually will happen to d? The g will decrease, whereas we have seen the value of g to be increasing. So which means this option is also wrong. So the available option here is B. So that's the correct answer for question 5. The student. Okay. So the more acceptable option will be B. Next question. The rocket is accelerating horizontally due to a constant resultant force. The mass of the rocket decreases steadily as it uses up its fuel. Which graph shows how the acceleration of the rocket could change? Now, in this question, you are looking up at constant resultant force. So what's the formula of resultant force? Force is mass times acceleration. Now, this force is remaining constant according to this situation. So if the force has to remain constant, either these two unit quantities has to remain constant, or if these two quantities are changing, it should change in such a manner that they should complement each other. Now let us say what is happening here. The mass of the rocket decreases steadily as it uses up its fuel. So mass is decreasing. Now, if one of the quantities is decreasing, the other quantity should increase to keep the force constant. So, which leaves out, which gives us the option of B, because out of these four options given, only acceleration is increasing. Now, two arrangements P and Q of identical springs are subjected to the same tensile force as shown. When one spring is subjected to a tensile force F, the elastic strain energy for the spring is E. Which row of the table gives the total elastic strain energy for each arrangement? Now you have to look at it. These two arrangements are, this is a series arrangement and that's a parallel arrangement. Okay. In a series arrangement, the extension increases. In a parallel arrangement, the extension is smaller compared to that of in a series arrangement. Okay, so when the extension increases, the elastic strain energy also increases. So gives us the option of C and D. So elastic strain energy will increase because they say for one force, if it's E, there are two springs involved. So two forces will be involved. So it will be 2E. So we have the option C and D as 2E. Now, as I told you, parallel springs, the extension will be decreasing. So which means the possible option that we have here is D. So the elastic strain energy of the spring in series increases, whereas the springs in parallel decreases. The velocity time graph shows the motion of a particle with a constant acceleration. P, Q, and R represents the magnitude of each of the area shown. Which of the following expressions gives the total displacement of the particle? Now, this is a velocity time graph. A velocity time graph, the area under the velocity time graph represents the distance traveled by the object in a particular direction, which we call displacement. For an object, if an object is traveling in this direction, the positive direction, the le, let's say the velocity of the object is increasing with respect to time. So this gives the area under the graph for the motion of the object. So r represents the motion of the object in the positive gradient. When we come to the negative gradient, this q represents the area under the graph for an object in the negative gradient. So we have an answer which is r plus minus q. Why is it r plus minus q? Because q is in the negative gradient. So that gives us the form value r minus q, which is D. Question number 9. A cyclist rode along a slope at constant speed. The increase in vertical height of the cyclist was delta h. The slope was at an angle theta to the horizontal shown. The forward force of the road on the bicycle was F and air resistance was negligible. Which of the following gives the work done by the cyclist? So we have the formula for work done as force multiplied by the distance traveled in the direction of force. We have a force in this direction. They are saying forward force. So we need to consider the distance in the direction of force, which is this. So x represents the distance in the direction of force. We don't know x, we only know h, delta h, but we also have angle. So using trigonometry, we have sine theta is delta h over hypotenuse, which I consider as x, which is the distance traveled along the slope. So your x will be delta h over sine theta. So your work done will be force multiplied by delta h over sine theta, which gives us the option D. Question number 10. When compressed by a force of 50 Newton, spring had a length of 12 centimeters. When compressed by a force of 70 Newton, the same spring had a length of 7.1 centimeter. Which of the following expression gives the stiffness of the K? So let's use the Hooke's law formula. Hooke's law formula is K times delta X. Now we have two forces involved. So this gives us delta F equals to K times delta X, or K is delta F over delta X. So what's delta F over here? It's difference in the forces over difference in their respective compressions. So though we can consider X to be either extensions or compression. If it's extension, the spring will increase in length. So if it's compression, the spring will decrease in length. So you will have to consider the decrease in length. So your answer will be now minus 7.1. We include minus sign to represent the decrease in length. Okay. So that gives us 70 minus 50 over 12 minus 7.1. So that will be